Ow! That hurt. Ow, much more than you think it did. We've all heard this story before. This is the story of how Isaac Newton magically discovered the principles of gravity. But is it? As a matter of fact, this painstaking process never happened with Isaac Newton. Yes, it's just a common myth. He never had an apple fall on his head. In the next 5 minutes, I'm going to share with you what really happened with that fabled apple. You see, Newton never had an apple fall on his head, but he did think a lot about why an apple always fell towards the ground. After a few months of further observations, he came to the conclusion that a body, when freely suspended, always fell towards the ground. This is what he called gravity. And in an audacious attempt to unify the universe, he said that gravity was the reason why planets orbited the sun, why the moon orbited the planet, why planets even exist, and why the universe is the way it is. He also came up with 2 mathematical equations that helped us determine the effect of gravity on occasions. And those equations were spot on. We could even launch satellites with these equations. It was truly a huge step for mankind. But there was something that was not right about this. Newton explains gravity as a point-to-point force. In this video, you can see that both bodies are exerting forces towards each other. The tension in the rope represents the direct force applied by both bodies on each other. But as you can see, as soon as one body stops exerting gravitational force on the other body, it feels this effect instantly. This experiment shows what Newton said about the characteristic of gravity: instant. We just saw an experiment which showed what Newton was trying to say about gravity having an infinite range and the force being instantaneous. Whoa! Whoa! Hold on a second. Does that mean that all of you and me are being affected by the gravitational effect of every single star, every single planet, and every single black hole that's ever existed? This seems a little crazy, seeing that we don't become disfigured by 1 trillion gravities affecting us. But nobody raised a question for 150 to 200 years, till a patent clerk with the name of Albert Einstein challenged his theory. Einstein's mathematical equations showed that gravity only moved as fast as light, and he contested Newton's theory on this basis. This meant that if a body was to stop exerting its gravitational force on another body, which was really far away, then it would take seconds or even minutes the effect to reach there. But this meant that gravity also moved. And to show this, Einstein asked us to combine the 3 dimensions of space with the 1 dimension of time to give layers of space-time. In this experiment, the cloth can be taken as a single layer of space-time. The basketball can be taken as a sun. The curvature caused by the basketball shows the extent of the gravity of the sun. It bends space-time. The small ball can be taken as the earth. And we can see how the curvature manipulates the ball to go around the sun, hence causing orbits. We also see that every single mass bends space-time somewhat. The extent of this bend depends on the mass of the body. We can conduct another experiment to understand this better. Here, the water shows the multiple layers of space-time. The plastic cap shows a planet. Any disturbance to the ball, which can be taken as a star, causes the waves to be formed. This is how gravitational waves are formed, and as you can see, they travel at a limited speed. This shows how gravity is not instant and its effect dies down over time. When the ball is taken away, the last wave is still propagating as it takes time to reach the planet. This helps us understand how gravitational waves behave and how they take time to reach a certain body. This is what Einstein theorized as gravity. Continuing Einstein's take on gravity, we recently discovered that gravitational waves do exist. But what we also saw in this theory is that every mass bends the space-time. We saw how it bended space, but this means that it also bends time. Hence, an effect called time dilation occurs. My name is Abhishek Iyer, and I hope you thoroughly enjoyed this video. I hope it helped you gaining a wider perspective of how gravity has changed from what we considered as Newtonian gravity to what the theory of gravity proposed by Einstein. Thank you.